And this is my final guest, Linda Angulo Lopez, and she's a botanist and sustainability hacker, and she will be discussing emissions in California during the pandemic. Linda?
Hi there, Tara. Thank you for having me.
Thank you for joining today. Can you give our watchers and listeners a little background about yourself and why you decided to research emissions?
Well, I'm a botanist, as you said, and I came to France 20 years ago, and I've been a mom for the last, well, I'm still a mom, I haven't, but I decided to start studying again, so I took a course with UC Davis, and it's a GIST course on a spatial analysis, and it was, I just chose this as a project because I really wanted to learn more about satellite image analysis, in fact.
Can you give us a little more information about ArcGIS, the system that you use to do the analysis?
So it's not an open software. It's you have to have a license with ESRI, and when you take the course, they actually give you a license for a year. So the work that I did, I cannot use it to gain income. It's I will upload the data, and if anybody needs the data, I will share it with them. So they just need to contact me. It's just, yeah. It's a type of software to analyze to create maps and to analyze geospatial information.
Okay. And would you like to begin your presentation on the research that you've done?
Yes. So let's share screen. So in fact, the presentation, I started off with NLT2 emissions, and I know there's some confusion about NO2, CO2. There's a lot of O2s happening. So in fact, my motivation, just to show you, so the output, the final output was an app, a geo app, where you can actually look at the map with the emissions. You can take a survey, you can contact me, you can look at the map with the impacts on the ecological areas as well. So just to explain to you my motivation for the study, in terms of, there are many impacts there. So I'm not sure if you know Kate Rawford and the idea of the donut economy. So it's a bit like, the Sustainable Development Goals. Okay, so what she does is to take, you could consider this like the Sustainable Development Goals, and these are the ecological factors, in fact. So she integrates both of them, and so to have a sustainable development, what you need to consider is both the ecological factors and also the human factors. Okay, so her concept is to be thriving as a society. We need to be within this green donut, she calls it. Okay, it's a space where you balance the ecological needs of the earth and the human needs. Okay, so what we have here, in fact, is in today's state of the world, we have the issue of climate change. Okay, so this is why there is this big motivation for CO2 emissions. In fact, CO2 is one of the most important emitters because we are burning it so quickly. And then my motivation personally was really to do about nitrogen loading. So it's not exactly the same motivation, but there are overlaps, in fact. So you have overlaps like nitrogen loading. It affects climate change very slightly, but it has a very big impact of biodiversity loss. My motivation, the second part of my project will be to calculate nitrogen dioxide pollution. It affects vegetation, and also vegetation affects or improves the air quality. In fact, my motivation, the next step is to go towards this. The first step was just to quantify, in fact. Okay. And this is, I don't know if you did this at high school. You remember this?
Yes.
So the problem is we have what we call the disruption of the nitrogen cycle in today's society. You have a double. There's actually twice the amount of nitrogen being produced than what was available in the natural system. The impacts of this overproduction of nitrogen is that we have ozone, which is dangerous for human health. And then you also have pollution of the waterways and things like that. Just to explain the satellite image I chose to take, there are different analysis you could do. But because nitrogen sits here at the troposphere near the ground, I use images that capture the nitrogen at that level. So this is an image of what the satellite does. So the sun, it shines on the earth, and the light bounces off, okay, of the earth, and it also bounces off clouds, etc. And the satellite, it captures all the light. In fact, it's UV, the radiation, and so my analysis, it's not like a very high level analysis. The people at NASA, what they do is they take the radiation and they do a calculation, and then they give us an image. So you can search and you get an image over the area you want with a type of like a square, mm-hmm. which has a special, which has a color that is linked to a quantity. So you can do it for a lot of particles. I chose the nitrogen dioxide particles. So you get, and then the problem with this analysis is when you have a lot of cloud cover. So if you have cloud cover over 30% of an area, you do not get an image, okay? So, and good news, Tara. You guys are doing great in California. So this is, you have achieved sustainable growth from 2000 to, in fact, it was around here, 2006, when you guys really started achieving sustainable growth. So it's, the COVID, it did reduce the NO2 emissions. But because the EPA already had the cap and trade, and they had regulations to control power stations, there's massive drops of, this is greenhouse gas emissions, but it also includes nitrogen dioxide emissions. So you had massive drops. And California is, in fact, an example for the rest of the world, and how the cap and trade is functioning, how we call them in environmental regulations, we have what we call the carrot and the stick. So the carrot is when you reward people for doing something that improves air quality or water quality, and the stick is, of course, when you have a fine for polluting. So you have GDP increasing, population increasing, but at the same time you had greenhouse gas going down, okay? So this is like a great sign that you can achieve, and this happened around here in 2006 when the EPA put in place these measures, in fact. So COVID, yes, it helped a lot, but the big change was here when the EPA put in place these regulations. So the global warming emission sources, so this is for what you call global warming emissions, okay, not nitrogen dioxide emissions. And this is the state of affairs as it is now. Of course, transport is just something that just never goes away. And industry, so you have electricity. Agriculture, you were concerned about, is 8%. there's a lot of slack given to agriculture, but in fact, there's a lot of pressure as well put on farmers. I myself, I come from South Africa, and my ancestors, my brother is a farmer, and I know the pressure that is put on farmers to produce. And in fact, you need to integrate what people are eating. I mean, a lot of our agricultural production goes for animals, in fact. So we need to really decrease our meat consumption. So just to talk about, when you, just to link the two together, the NO2 and the CO2. So for 1 gram of nitrogen, it's the equivalent of 298 grams of CO2. Okay, so it means it has a bigger impact. But luckily, well, I don't know if it's luckily or not, there's more CO2 that is produced. The worst is actually the sulfur hexafluoride, this molecule here. But there's very little of it produced. So in terms of when you look at greenhouse gas emissions, what people are quantifying is the CO2 and the methane, and very little of the NO2. I'll show you in the next slide. So NO2 is like about 3% of the total greenhouse gas emissions in California, or was in 2004. That is not significant, okay, in terms of greenhouse gas emissions, but remember, it has significant impacts on biodiversity, and this is the problem, in fact. So you cannot only judge or evaluate a pollutant by one impact. Climate change is important, but there are also other things that are happening about biodiversity, etc. And in fact, climate change, the whole motivation is about the loss of biodiversity. So if you look at the impacts of NO2, okay, again, transport, it's really complicated, in fact, because you have agricultural soils and organic or inorganic fertilizers. Both of them are going to pollute, okay? And then you also have the crop itself. So you have the leguminaceae, like the beans, which capture nitrogen and give off nitrogen. So you cannot just by quantifying something saying it's good or bad, okay? Because it's better, in fact, to eat the legumes as a protein than to eat meat. I'm not vegetarian or anything like that, but just in terms of ecology, it's complicated. It's not just a matter of numbers. So I did this specialization on Coursera with Nick Santos. It's from California, UC Davis. So this is one of the data I collected, which is the EPA ground level emissions. And as you can see, this is California here. There are not many points, and I don't know why, but they have a lot of collection points here. I think this is where the Pacific oil and gas fields are, and smog belt here.
And larger cities.
Yeah, that's San Francisco. I think that's where you are, Fresco. So with the EPA, with ground level monitoring, you can only, because of the cost of it, you only have a limit of data collection points. And with the satellite image analysis, you can have 800 data collection points. Okay? When I collected the data, this is the sort of image you get. And these little dots, when I extracted from the image the number, okay, for the amount of NO2, and here you see this violet is very high levels, and of course it's here. This was during the COVID period. So I extracted a lot of images. There were 21 images. It's quite complex. But basically, this is the Los Angeles basin. This is the agricultural area. This is around Fresco. It's complicated because there is the interstate highway here, for example, and there are some regions that don't Like here is a natural area, but you have pollution here, probably because of Las Vegas. So I didn't collect data from the whole world. I just collected from California. So I'll explain the data better later on. And then I also created some points, okay, just to be able to put a name to the place to make more sense. So, for example, some of the points I added on did not exist with the EPA monitoring stations. So I chose some points in the forested areas and the reserves that don't exist with the EPA. So I merged both of the data, and you can go to this map. There's a link, and you can interact. This is just a presentation, so it's not interactive. And so if you click on a point, for example, you can see all the emissions I collected from January 1st, 2019 till June 2020. And then I also did some aggregations, so you can have a look at the data if you want. So this is the actual analysis project to show you the different maps I created with the images. I won't go into the technical details, but so that was the data extraction. And this might be more interesting for you, in fact, because what you see here is analysis, okay? From the data analysis, you can see there are just these three places, in fact, which are dominating what happens in the state of California. So it's Los Angeles, Riverside, San Francisco, Sacramento, San Jose. Sacramento and San Jose are really down here. So you have a cyclic effect where emissions really spike in February in these three regions, and it changes the profile of the whole state. In fact, this is why it makes no sense to take an aggregation of NO2 emissions of the state of California, because in fact, what you're going to have is just a view of what is happening in Los Angeles, in the big cities, in fact. If you look at the little towns like Fresco, for example, it's somewhere here. It's very stable. It doesn't really change a lot. But here you have cyclic effects. From March to October, you have a peak, and then this is April, then March to it's a repetition, in fact. So you have the cyclic effect, and this is the emissions comparing 2020 to 2019. So what you have, this is 2019, and this is 2020 here. So you can see there's a big difference. So that's, for example, 2020, and that's 2019. So you have a massive drop in emissions in Los Angeles, Riverside, everywhere, even in the forested areas. So what happens here in the big cities, it impacts on all the other players, in fact. So what I did is an overlay of the ecological regions in California. So you have the big problem, in fact, is the Mediterranean California, which is this region here in red here, is literally cut in half by the pollution in Los Angeles. So this is the good times during COVID, when everything went down. So in the good times, it's cut in half. So you have a problem with. I've never been to Los Angeles or America, for that matter, so I don't know what is happening here. But I don't know how you can really change people's behavior. You had lower emissions, as you saw in the previous graph. The emissions went down, okay, from here to there, but it's still an important impact. It's still, at this level, you're still having NO2 is what we call a short-lived species. So it transforms into ozone. So when you see purple, it means that it's becoming ozone, and which is dangerous for human health. So people who live here probably have problems with respiration. It's quite dangerous at these levels. You have other areas, a Bakersfield. So that was the quick presentation. And then I created a survey, and there's also the web map. I don't know if I went too quickly.
No, you're good. I'll make sure to share your survey with our viewers and our readers so that they can give their opinion and give you some more data to be able to analyze.
Okay, thank you. Do you have any questions?
You were saying before that nitrogen and carbon dioxide, the small amount of nitrogen equals a large amount of carbon dioxide. Can you explain that a little more?
Okay. So in fact, each molecule has a mass, a size, okay? So carbon itself, when you add oxygen to it, it becomes bigger, okay? So it can absorb more energy. And because it does that, it means when it's in the atmosphere as carbon dioxide and not as carbon, it absorbs more energy and it heats the atmosphere, okay? And nitrogen dioxide is a bigger molecule, so it absorbs more energy. And this is why it has its impact on global warming is greater, because it holds more energy. I'm like oversimplifying it. The thing with climate change, in fact, the problem is with the water cycle. So what is going to happen is, because you have more heat energy in the atmosphere, water is going to evaporate, and you're going to have more water vapor in the atmosphere, and you're going to have more rain. So the water cycle is going to speed up. You're going to have more floods, more rain. The sea level is going to rise. So this is one of the most important impacts of climate change. In fact, it's the impact on the water cycle.
And it's cyclical because nitrogen affects vegetation, which is normally a way for processing carbon and reducing carbon because they absorb it to process it into oxygen.
Yes, absolutely. And so my motivation is, well, you can see here in this area, you have, it's a different ecotype. It's the cool desert is heavily impacted. And it's also a question about the vegetation type there, I think. So I want to investigate to see how the vegetation, because here you have the warm desert and it's less impacted, but it's probably because you have a different vegetation type. So it's two things. It's the impact of human activity and the vegetation type, and of course so here you have heavily impacted ecosystem that is just crazy. Almost the whole of the Mediterranean, California is polluted. It's quite bad. So my motivation is to see how vegetation impacts pollution and how pollution impacts vegetation, because you have different types of plants that absorb and produce different nitrogen dioxide. It's not very clearly well understood, so it's interesting for me to do this type of study. And I can do it with satellites.
Well, I look forward to seeing more of your research, and thank you for joining me, and I'll make sure to share your survey with our watchers and readers so that they can give you some input.
Okay, thank you.
Thank you.
Okay, bye.
Bye. Our sponsor today is also Darren Gibbs Industrial Equipment Repair. They do welders, plasma cutters, overhead lifting equipment, torches and regulators, air tools, cutting tool sharpening, hydraulic cylinders repaired and manufactured, make sure to check out their website for equipment that they have for sale at valley.equipment, or contact Darren Gibbs Industrial Services at 559-351-3280, or give them an email at contact@darrengibbs.com. And now we will have a moment of silence for our Black Lives Matter community.